manage basically all the 3D visual products that we have in navigation. To give you a bit of an overview about Navtech. Navtech is approximately 25 years old at this point and has specialized particularly in data management, in mapping the world, so to speak. So we traditionally made the digital maps we provided to the customers and implemented on a number of cases. So the first of all, what I'd like to point out here is we moved from the traditional mapping model, like the 2D maps that you've probably noticed, and the Google Maps, the traditional ones, or the MapQuests, Map24, MapTP, and so forth, to a digital model. This has really been a key step in the entire development and distribution of data. And it also opened it up to a number of other industries. I mean, from in-dash in automotive industries to telematics, of course, internet. Map24, for example, is actually the company was acquired by Navtech. Mobile devices, any smartphone, even feature phones, cell phones, of course, trip planning, fleet and enterprise. This also includes traffic data, branding of icons, for example, points of interest, turn-by-turn navigation, and of course, government at the same time. There's a lot of customers that we are providing this data to. Navtech is actually a B2B company, so we don't sell it, so to speak, to end users. There is not really much an end user will see from Navtech until it's implemented by one of our customers. Nokia, of course, being the biggest one, since it's our parent company. So Nokia owns Navtech, and as such, of course, it's integrated into OB Maps. Now, the visual portfolio spans across multiple different products at the same time. So, on the one hand, we're delivering the content to applications. And this is really the most important thing to point out here. It's implemented by our customers. So we are a data provider, as well as a software provider. So we also make tools. We also distribute tools. We support tools at the same time. And we're providing location-based information. So this ranges anywhere from location-based advertisements, location-based services, such as location of toll booths, petrol stations, or any other kind of service feature that you would possibly have on a highway or in the city. Of course, the visual guidance, we try to use visual guidance well, very much in a visual manner, so to speak. In other words, what we're providing is not just the 2D footprints, not just the 2D map, but everything that is linked to that. And I will go into that a little bit more detail later on. And of course, visual cues, and these are provided, again, via points of interest, via specific 3D landmarks, recognizable buildings that carry photogrammetric textures to make them recognizable, even in a navigation device, either for pre-planning or turn-by-turn navigation. And this also ranges anywhere from the automotive industry, the mobile industry, including pedestrian pre-planning, even mission pre-planning in the service field. And there are customers who are implementing that data in games as well. And there are a couple of navigation games where you navigate through a city and you drive a car and so forth. And there's other game companies that are also integrating this data because it's available. And it's, of course, also available in COLLADA, and we'll get into it as well. So something else to point out, and this is very important, and this is why Navtech is such a big company. We have, I think, over 5,500 employees worldwide. Approximately, I think, 50 offices across the world. And a lot of that is the field office. And the field offices actually drive the data. We have people in cars driving practically every day, every quarter, throughout at least all major cities and motorway junctions and highways, updating the information, integrating additional attributes, turn-by-turn commands, recording lane levels, and of course updating if there's any changes. So there's quarterly updates that in some cases are as large as 40% of all the data that's available. So if you consider that right now we're mapping approximately, I think it's 220 cities worldwide, ranging anywhere between 5 square kilometers to 120 square kilometers, that's a lot of data that has to be created and maintained, of course. Okay, so the use models that we're looking at right now too are, on the one hand, the highway, on the highway. And this includes such things as, for example, junction views. You've probably seen this in your own navigation device. You see the map, and all of a sudden, let's say a split screen comes up and shows you the exit. What does the exit look like? Which lane do you have to be on in order to exit correctly? Are there any signs? I don't know, how many of you have a Verizon phone, a VX1? Nobody? Well, do check it out. It's actually the first implementation of a full 3D city navigation in a mobile device. And I'll show you a little bit about what kind of data they implemented. Sure, go ahead.
I'd like to just say, I think the one on the left is the best.
We'll get into that. I mean, yeah, I think it all boils down to the visual cues, really. There's a lot to say about also the liability factor in terms of navigation, and the most important thing, of course, for us is recognizability. I mean, it has to be recognizable, particularly on a small display, and this is really key. And this is why I really recommend checking out the VX1, because it does actually, on a fairly small, I think it's like a 4-inch display or 3.5-inch display, integrate a full 3D city. And it's recognizable. I was a bit doubtful myself, I have to admit, I probably shouldn't be because I've probably managed this. But it's interesting to see it in the small display and see it working in the small display. And it is recognizable. There's other factors that we have to take into account there as well. I'll get into a little bit of that more later. And so it also depends on the system requirements. On the one hand, the good approach, so to speak, the approach that most of us are used to, or that you'll see in OV maps, Nokia maps, for example, is the normal footprints. Now, these footprints are based on sourcing by driving through the city, satellite imagery that's being sourced, as well as aerial photographs that are being sourced. From that, we also derive the 3D city models, and there's approximately 220 of those of various sizes that have these kind of 3D models of the cities. And then last but not least is the visually best approach, and that's the one that's being implemented also in in-dash devices in the automotive business, which is the textured buildings, plus of course the photorealistic 3D landmarks. COLLADA is the transport format of choice for us, and there's a number of reasons for that. I mean, on the one hand, it's platform agnostic. I think this is really the key factor. Since we provide data, we need to make the data as accessible as possible to our customers. And COLLADA, it pretty much combines the best of both worlds in terms of size and manageability, and of course portability. So this has been very key to our success there, delivering that data in also a fairly small memory footprint. And I'll talk a little bit more about this in a minute as well, because really it does make a huge difference how this data is transported from one platform to the other. The customers usually take this data, the COLLADA data, and then compile it into binary. On the one hand, simply because their system requires different kind of memory footprints. It may require different kind of implementations in terms of the renderer, which then of course means sooner or later they'll run into issues if they keep a file format that is large or too small, or it's not manageable, and then of course ultimately it's security. Since most of these customers do a fair bit of customization work on the data we provide them, and the unique solution that we provide to their end users needs to be protected, which is ultimately why they compile it into binary. But again, for us the most important thing is it's cross-platform compatible. It includes a lot of metadata that is included and stored in the COLLADA itself. This ranges anywhere from points of interest to turn-by-turn commands, even the splines, I'll show that later on too, the navigation splines on the street that are coded and that have all the attribution to provide the customers with the turn-by-turn commands and navigation instructions. And last but not least, of course, it's compatible with practically any API out there. Now, the way we implement COLLADAs, naturally, if you have a city like Singapore with 120 square kilometers with 3D geometry, that's going to be a big COLLADA file. And you always have to consider that these kind of COLLADA files have to be pushed into the memory and have to be displayed and have to be rendered, which is ultimately where we went for a tiled approach. So we're going for tiles that are approximately 400 by 400 meters in squares. That include the buildings and the streets and everything else. It's pretty complex because it all has to reference back into the map. So everything has to still be geocoded, so all the data has to be there. We have textures, mostly PNGs, in various levels of detail. Same goes for the geometry. So the geometry is available in fairly high resolution, for the data model, and of course a lower resolution in case, let's say, a smartphone may not have the rendering power, the GPU power, to provide the kind of rendering performance. So the one other thing we do in order to make it easier for our customers to manipulate that and create their own unique solutions is we go for XREF layers. References, I mean, it's pretty well known in the 3D industry, what XREFs are. It's basically instances. In other words, if we have something such as a tree, shrubs, vegetation, toll booths, petrol station, and so forth, that are repeated over and over and over again, we do not want to include the description, the geometry description, and the texture description of every single tree in that model within the main COLLADA file. That would be absolute murder. So what we did is we just reference the location to a separate COLLADA file that includes the geometry, which also makes it easier for our customers to just go ahead and swap out entire vegetation or huge amounts of texture to make their own unique look. So this is an example of the tiles. So in this case, for example, I think this is Chicago, and what you're seeing here is about 16 different tiles of 400 by 400 square meters in length each. So each one of these tiles is included in a separate COLLADA file, a separate DAE file that gets transported again to the customers. And we have a server-based setup there that's available 24/7 that the customers can always download the updated information from. And this is an example. This is Munich, Isartor to be exact. And what you see here, right, this is actually the roadbed center. We have two different spline models, roadbed center and lane level. Lane level being split into a spline for each lane with instructions for each lane. So for example, in this case, this may usually have the attribution of the commands for just the right turn, and then maybe the middle lane is the one that goes straight but cannot turn right. This is also included in the lane level splines. But this right here just gives you an example of the complexity. So you see the footprints of the buildings, which is used to create most of the buildings themselves. And then of course each spline, which includes the instructions. There are certain points, like here for example, that instruct, or I think this one actually is the right one. This, what we call a PVID, a link ID, tells the customer to throw up a command saying you're going to have to turn at about 100 meters, or you're going to have to turn pretty soon, or turn at the toll booth, or turn at the red building, something like that. So this is all data that's coded directly into the cloud. Again, textures, so you can switch out the textures any shape and form you like. And we have customers who build night and day textures for their cities, with lit buildings, for example. It's very easy to do. It's just PNG files. They're referenced in a separate folder. The hierarchy is pretty straightforward, and it just references to those PNG files within the COLLADA file. And of course, it depends ultimately on the rendering model of our customers, what they're using. This is a pretty bland ambient lighting look. No shadows, no highlights, or anything. But it gives you an idea of the geometry and the complexity itself, and this is what the customers can implement, and then it's up to them whether they want to go for a lit, like a parallel lighting approach, or even one that includes highlights and shadows. So this ultimately depends on how the customer implements it, and it depends what the system requirements are that they have. You'll probably not find this kind of look on smartphones anytime soon, but you will find it in in-dash devices or PNDs. And this is another example. This is Chicago, again. And as you can see, there is a whole lot of vegetation going on. Again, this also depends on the instancing approach that our customers take. The COLLADA file itself does describe the location of each one of these trees, which then points to a separate COLLADA file for the tree model, or multiple tree models, how the customer wants to implement it. And then it's, of course, their choice if they want to go for an instancing approach and just try to optimize the rendering, or they want to display all the geometry, or it's completely up to them how they implement it. So another look of Chicago, and again, this is just a small section. what I showed you before, like this section right here, this was 4x4 tiles, basically. So less than like a square kilometer, and Chicago has 40. So the entire model is 40 square kilometers in size. And this is not even the biggest one. In Singapore, it's 120. Okay, what I'm going to do, actually, hold on, one thing I also want to point out, I almost forgot. We do have developer support as well. We have a developer website, Navtech, Network for Developers, N4D, and we do provide APIs, SDKs, third-party SDKs, data models, documentation, information, and so forth that our customers need to completely implement their own navigation options with all the products that are available. Now, this ranges not just from the 3D model, but also 2D models, 2D vector icons, vector graphics for the signage on a highway, for example, and of course the motorway junction objects. We actually have approximately 7,000 motorway junctions that are completely mapped in 3D, also including instructions and links and attributes for the actual exits for the highway, the signs, the complete mapping and turn-by-turn navigation on the highway. And what I'm going to do right now, do something a little bit more exciting. Oops, hold on. There you are. Okay, so this is something else we provide for our customers to make it a little bit easier to implement the stuff and see what it looks like. So our 3D content viewer, the 3D content viewer, it's DirectX based. It just loads the COLLADA files. So as you can see here on the left-hand side, these are all the COLLADA files that are implemented. They do come in various flavors. So you've got the high, medium, and low LOD, and of course also the spline file that is integrated for the turn-by-turn navigation. And let me just zoom out. So I don't know how many of you have seen source code. You know, this is that thing that Jake Gyllenhaal runs around at the end of the movie, the chrome beam. And I think they did a pretty good job mapping it with a reflective texture map. And you actually have to stand in front of it to really see it. It's pretty large. It's like 3 meters high and 6 meters long. It's gigantic. As you can see here, so this is the entire city, and there's a couple of models such as these ones, which are 3D landmarks, so they carry slightly more realistic textures and photographs as well. Let me actually zoom out. And right now, also what I'm doing, it's constantly streaming, of course locally, streaming the data. So it always depends what the rendering model is. So as I move around, it does come up with additional portions and tiles of the city. So, oops, sorry about that. So this being I think this used to be the old Cotton Harbor building that Navtech used to be in. Now they're no longer anymore. Now we're in the Boeing building. Yay! And again, I mean, this loads the entire COLLADA model directly into memory, and then, depending, of course, on the performance of your system, loads the tiles and brings them up. And this is really what is key to our customers as well. This is what COLLADA is great at, because it's very easy to just load and unload this into the render engine. Yeah?
So I'm seeing some overlap between tiles. Is it that when you need to pull up something that's on another tile, that it overlaps on another tile, if you load up that tile, does it also have a copy back of the same?
Yeah, there's definitely geodata referencing going on there between the COLLADA files, so we actually know which COLLADA file ends where and goes where. Particularly difficult when you have buildings that fall directly on the border of a tile. So we have to decide, okay, where is the building? On this tile or that tile? So this is something pretty unique too. Just making sure that it all links back to the footprints, of the map. So we know which COLLADA file and which building is referenced in which tile, and it's attributed to which footprint. And of course, if there's POI information, let's say, and this is the Hancock building right here, the Hancock Tower, this one falls directly on, actually I can show some of that as well. So yeah, this is the grid. Okay, this one fortunately does not fall directly on the border, but there are other cases, I think, like, well, not quite, I thought this one did. So I think in this model we've been fairly lucky because Chicago, just like New York, is a square model of the street, so it's a little bit easier. If one building falls on one of those borders, all of them will. And then briefly, So this is the lane levels that you have that include the lane instructions and the navigation instructions for each lane. And this is also coded directly into the COLLADA file and attributed for our customers.
Well, what I was wondering about is, like, if you were to move up to the dock, there's, I think that dock was overlapping quite far into the other tile, and then that tile loaded, and I couldn't tell if that tile also had the dock in it. If you like result.
In this particular one, let's see, what I probably have to do is zoom out a bit so I can. So it loads too quickly for me to tell. That's part of the problem. No, but like I said, it's in the COLLADA file itself. It is referenced, so it does know which buildings are. There's a bit of a threshold going on here. There's a bit of overlap and threshold fully overlap, where you can actually tell, okay, this building is mostly in this area, not quite in that area, so it's going to be included in one of the tiles, but not in the other.
Well, yeah, there's an option as such. You just
Cut it off. Right? I mean, that's an option that our customers can do. I don't know why anybody would, but yeah, it's possible to just cut it off at the border, or you can also leave it overhanging.
I think maybe they're seeing an illusion from the tile, the building reaches up and it looks like it's crawling into the next tile.
So, I mean, again, for the most part, it's too quick to actually tell. So this is the wireframe model of the high geometry. It's fairly optimized. We are dealing with triangles, but it's pretty optimized. It does include a fair bit of elevation models, but for the most part, the DTM data is integrated into our motorway junction objects, not into our cities quite yet. But it's something we're looking at as well. Of course, for cities, you need a much higher resolution DTM than you do for a motorway highway junction.
Excuse me?
Yeah.
Since COLLADA measure our pre-processing in order to deliver in trouble, so that will affect the load time. Like, for example, for each vertex attribute, some of them, they have separate indices. So you have to now make it into the master index and sort of reprocess all the attributes. So when that happens, do the load time or?
This completely depends on the implementation of the customer. So I mean, again, like somebody like Verizon, for example, has to stream a lot of data via their smartphone, whereas customers, let's say like BMW, it's all on the hard drive. So it's a completely different issue that they're dealing with, as opposed to, for example, a mobile provider. So again, this is something very important to point out. We don't actually make the navigation model itself. I mean, we make the data, we provide the content, but ultimately it's up to our customers to build that into a user experience. But yeah, we're providing petabytes of files worldwide that our customers can download. All right, there's no further questions. I'll give it back.
Yeah.
One more
Yeah,
question.
one more about the navigational splines and stuff. That's all GIS data, so it's like latitude, longitude are embedded into the model definition.
Right.
Is it your own kind of node type, or?
Yes. What we do, like I said, we actually run the entire model via the cars. It's attributed directly via active sourcing, so to speak. So we don't source third-party data for the streets. We do make them ourselves. So it's not we're not sourcing CityGML or ArcGIS any of that. We actually create the map ourselves. Yes.
Sort of related to that, I was going to ask about internally. You're talking about how you're always updating and expanding this database. Do you maintain all the 3D data in COLLADA format yourself, and how do you update that data, or do you maintain it in some other format and you publish the COLLADA data from that?
We publish the COLLADA data. We have our own tools to create the cities. So what we usually do is we have our own tools for the 2D map. And that's where the field inputs all the mapping data that is updated on a quarterly basis. And this is also what the 2D map comes from, and all the other attributes. And the amount of data that actually goes into the 2D map is enormous. This gets fed into a separate tool that then creates the 3D buildings out of that and exports it in the COLLADA Ruby. Thank you very much.